Ladies and gentlemen, this is Miss Humbert here. Today I'm going to be doing Unit 8, Notes 5. So I'm going to be talking about solving radical equations. So I'm actually going to be splitting this note video up into two parts. It's actually going to be better for your learning if you just do the first part. So I will give you your practice sheet after you've done the first part of this note, because it's actually better to watch the first part of the note video, try those parts on the practice sheet, and then watch the second part, because the second part might be confusing if you don't get to practice the first one first. So try and put it into pieces like that. So let's go ahead and let's take a look at how you solve radical equations. So the first thing you want to do is isolate the square root. So if there's a constant, you're going to want to add or subtract over to the other side first and foremost. If there's a coefficient, meaning there's something being multiplied by that radical, you're going to multiply or divide that over to the other side. Then, in order to undo a square root, you need to square both sides. So that's how you undo a square root. Then, once you've squared, you should have the variable out from underneath the square root, and you can solve it as you would a normal equation. So the square root of x only has a positive solution. So if you ever have something that's set equal to a negative number, you're going to go ahead and say no solution. So, for example, if you had the square root of a is equal to -1, that, for example, would be no solution. And I don't know what the second box is for, so I'm just going to put a smiley face in it. Okay, so when you take a, the square root of a, and you square it, that's going to be a, because it's undoing a square. All right, so let's take a look at some examples of these. So again, remember the first thing you want to do is get that -7 over to the other side. And I'm getting really sick of using black pen, so I'm going to change colors. Okay, so what I want to do is get that -7 over to the other side. So I'm going to go ahead and I'm going to add 7. So I get the square root of x is equal to 7. So then I want to undo this square, because now that square is all by itself. So since it's all by itself, I can undo the square the square root by taking the square. So this guy over here is just going to become x. Remember, what you do to one side, you have to do to the other, which is why I squared the 7. So then I actually need to take and I need to do 7 squared. And when I do 7 squared, I end up getting 49. So x is equal to 49. Now, number 2 is kind of confusing because we have that coefficient on the outside, but we actually have square roots on both sides. So what I'm actually going to do is I'm going to square it right away to get rid of those square roots on both sides. So the square root of x squared, well, that's just, that's just going to cancel to x. So now I need to take and I need to square each part of these. So the first thing I'm going to do is I'm going to take 2 and I'm going to square it. Then I'm going to take the square root of 3 and I'm going to square it. So I squared, you'll notice, each part. So I get x is equal to 2 squared, which is 4, and then the square root of 3 squared is 3. So those two answers, once I've taken the square of both, are going to be multiplied. So 4 times 3 is 12. So my answer for number 2 is that x is equal to 12. Next, let's take a look at number 3. So, in order for us to take the square, what I want to do is I want to get that 3 over to the other side. I want that radical, because it's the only radical, to be completely by itself. So the first thing I'm going to do is I'm going to divide both sides by 3. So then I get the square root of x plus 4 is equal to 5. So now I need to undo that square. So I'm going to take a square of both sides. So on the left side, when I square the square root, I'm just left with what's underneath. So I'm just left with that x plus 4. Then I'm going to take 5 and square it, and I'm left with 25. So now I'm just going to solve this as if it were a normal equation. So I'm going to subtract 4 from both sides, and I end up getting that x is equal to 21. So that's my final answer for number 3, is that x is equal to 21. Number 4 is going to be the same. I need to get that 8 over to the other side, so I'm going to divide both sides by 8. So then I have that radical completely isolated by itself, and I end up getting 16 divided by 8, which is 2. So now, since that radical is all by itself, I can go ahead and I can square both sides. Well, when I take the square of a square root, I'm just left with what's underneath, and I'm left with x minus 3. Then I'm going to take 2 and square it, and I'm going to get 4. So then I want to just solve this like a normal equation. So I'm going to add 3 to both sides, and I end up getting that x is equal to 7 for number 4. All right, let's take a look at number 5. So for number 5, the first thing I want to do is get rid of this constant, this 9. Okay, notice that that's not underneath the radical. Since the radical stops after the 3, that 9 is not underneath the square root, which means I need to bring that 9 over to the other side. So I'm going to subtract 9 from both sides. So then I get 2x minus 3, that's going to be left underneath the radical. And then I'm going to have 5 minus 9, which is a negative 4. Now think back to what I talked about at the beginning of this lesson, and that's that a square root of a variable has to be set equal to a positive number. Well, that's not the case here. It's set equal to a negative number. So this one has no solution because my radical is set equal to a negative number. Now, that's only true once you've got the radical isolated. So once I isolated the radical completely and I was ready to square it, I had a negative number. So that's why I had no solution. Taking a look at number 6, I need to get that minus 2 over to the other side. So since it's negative, I'm going to add 2 to both sides. So then I end up getting the square root of 3x plus 1 is equal to 6 plus 2, which is 8. So now I have that radical completely isolated. It's set equal to a positive number, so I can go ahead and I can square everything. Well, when I square that square root, I'm just left with what's underneath, so I just have the 3x plus 1. 8 squared is going to be 64. And now I'm just going to solve this like a normal equation. I'm going to subtract 1 from both sides, and then I'm going to get 3x is equal to 63. Then I'm going to divide 3 from both sides, and I end up getting that x is equal to 21 when I solve that equation. Curious if you did it right? You can always take this and plug it back in for x, and it should work. When you solve out that equation, it should be equal to 6. Just something you could be doing on a quiz to make sure you're doing it right. Okay, so taking a look at number 7. So for number 7, I need to get that 5 over to the other side. So the first thing I'm going to do is I'm going to divide both sides by 5. So then I end up getting the square root of x plus 1 because these 5s are going to cancel out. So I'm just left with the square root of x plus 1. And 5 over 5 is 1. So then what I'm going to do, since that radical is isolated, is I'm going to square both sides. Well, when you take the square of a square root, I'm just left with x plus 1, and 1 squared is just 1. So now I'm going to go ahead and I'm going to subtract 1 from both sides, and I get that x is equal to 0. Okay, so x is equal to 0 for that one. Let's take a look at number 8. So we need to think about our order of operations when we're solving equations. So the first thing you want to do when you have a multiple steps like this to isolate is you want to get the constant, the thing that's being added or subtracted over to the other side first. So the first thing I'm going to do is subtract 5 from both sides. Then I get 3 times the square root of x minus 4 is equal to 23 minus 5, which is 18. Then I'm going to take and I'm going to divide both sides by 3, and I get the square root of x minus 4. 18 divided by 3 is 6. So then, now that I have that radical isolated, I'm going to square both sides. So when I square a square root, I'm left with x minus 4 underneath the radical there, and 6 squared is going to be 36. So now I need to finish solving this for my x. So since it's minus 4, I'm going to add 4 to both sides, and I get that x is equal to 40. So that's my final answer for number 8, is that x is equal to 40. So that's going to conclude the first part of your note video. Again, I want you to wait to do the second part until you've gotten a chance to practice it in class. So you'll do the second part in class, so make sure you're bringing some headphones tomorrow. Thanks. Make sure you take your Schoology quiz for the first part as well. Thanks for listening.